Okay, so welcome back. This is part 3 of our video today on tornadoes. So as I was mentioning, that's kind of what the Storm Prediction Center does. They put out the convective outlooks. Another thing that will happen, but this more from the National Weather Service, is they will put out the tornado watches and also the tornado warning. So much like a severe thunderstorm watch and a severe thunderstorm warning, with a tornado watch, it means that conditions are favorable for something to happen over the next couple of hours. Maybe a beautiful sunny day outside, no problem whatsoever at the moment, but they are looking for those tornadoes to develop a little bit later on. Tornado warning obviously means that a tornado has been spotted. Now that doesn't mean that a tornado has been spotted by someone. It can be a radar indicated tornado, but at the very least it means that a tornado has formed, and at that point you do need to be taking cover. So speaking of that, how does a tornado form? One way or the other, because you can have two thunderstorms next to each other. One could form a tornado, the other one may not. So we're still trying to understand why that happens. Even with all of our technology, I can't look at a thunderstorm or look at the thunderstorms developing and go, that one's actually going to create a tornado. We still don't know that, but hopefully at one point we will be able to. That will help us with our lead time and our warning time so more people can get to safety out ahead of those storms as they move through. So really there are two leading theories on how tornadoes develop. We actually can't even come to a consensus on this either. So the first one is, if you follow along with your PowerPoint, is at the very upper levels of the atmosphere, we'll see winds where the clouds are at about 25-30 miles an hour. A little bit closer to the ground, we'll see winds a little bit slower, maybe around 5 to 10 miles an hour. So what that happens is it creates a little bit of a roll in the atmosphere. These winds are moving faster than these winds, so the air starts to roll just a little bit, kind of like that. Well, what happens, at least in theory, is that because the air is rolling, kind of like this, but because you've still got the updrafts feeding into that cloud, that little roll, it stays elevated. It stays up into the atmosphere. However, eventually, as we learned with the thunderstorms, those downdrafts are going to take over, and you're eventually going to get downdrafts coming out of that thunderstorm, bringing the rain out of it as well. But also, at this point, it'll take this little spinning and pushes it down more into a vertical. So that's what creates the tornado. So again, you've got stronger upper level winds, weaker winds a little bit further below that. You create that spin in the atmosphere, which is being held aloft by those updrafts, but eventually gets pushed down into a vertical about the downdraft. And actually the picture in the PowerPoint shows it a whole lot better than my little demonstration right there. The second one is very similar, kind of, but with this you'll be having winds coming in at the surface from, say, the southeast. So you've got winds coming in from the southeast. In the upper tops of the atmosphere, you've got winds coming in from the west. So you've got winds coming in from two different directions. Again, it's going to create that spin in the atmosphere because you've got winds coming in from two different directions. The air gets very turbulent and it starts to spin. Again, at this point, this spinning tube of air is horizontal to the ground. But eventually that updraft comes along to feed that tornado or that thunderstorm, and that lifts the spinning roll of air into a vertical, and that creates a tornado. So this one just mainly dealing with updrafts, really no downdrafts, unlike the other one, and also winds coming in at two different directions. I really think this is what caused the Tuscaloosa tornado when I was back in 2000, when I was working for a television station, because as I was going into work that morning, I got stopped at a red light, and I was kind of peering over my steering wheel, and the clouds, the low-level clouds were moving one direction, and the upper-level clouds were moving a completely different direction. So I really think that's kind of what helped cause that tornado, and that one was an EF4. It did kill several people that day. I think that created that roll in the atmosphere, and eventually that roll got tilted into the vertical, and that's what helped create that tornado. So, again, kind of two leading theories on how our tornadoes develop. So then we kind of talk about ranking tornadoes. Unlike a hurricane, where we know the strength of the hurricane before it makes landfall, because we've got planes flying into it, we've got satellites taking readings of it, it's going to pass over buoys and other things that are also going to take readings of it as well. We know how strong it is. On the flip side, with a tornado, we really don't know how strong it is until after it's passed. Because a day or so after it passes, the National Weather Service will send a team out and they examine the damage. And based on the extent of the damage, then they say, okay, this was an EF4 or an EF5 or an EF3. So that's kind of how we know exactly how strong it is, but after the fact. Now, you know, if it happens to be caught on camera, we can look at it and go, ooh, this is a monster storm, or this is a very weak one. But we just don't know the exact wind speeds at that point. So actually, I'm going to hang on for just a second. I'm going to end this right now, and then we're going to come back with a look at the Fujita scale and talk about that for just a little bit. And we'll be right back.